तो आज अपन स्टार्ट कर रहे हैं एसएचएम, चार्ज में एसएचएम, मतलब हम टाइम पीरियड्स निकालेंगे चार्जेस का, वो कब एसएचएम करता है और उसकी इक्वेशन निकालेंगे हम टाइम पीरियड्स की। ठीक है, स्टार्ट करते हैं। अच्छा, इससे प्रीवियस हमने पूरा इक्विलिब्रियम तक कर लिया है, इक्विलिब्रियम ऑफ चार्जेस और इक्विलिब्रियम ऑफ सिस्टम ऑफ चार्जेस, दोनों ही लेक्चर्स हमने कर लिए। और अब हमारा ये है कि दो चार्जेस हैं, मान लीजिए प्लस क्यू और ये भी एक प्लस क्यू चार्जेस है, और मैंने एक दूसरा चार्ज मतलब तीसरा चार्ज प्लस क्यू एकदम सेंटर पे रखा हुआ है। इसकी डिस्टेंस टोटल मान लीजिए ये यहाँ से यहाँ तक ए और यहाँ से यहाँ तक भी ए डिस्टेंस और ए डिस्टेंस। ठीक है, अब क्योंकि ये चार्ज सेंटर पर है तो इस पर नेट फोर्स कितना आ रहा होगा, 0। इस पर नेट फोर्स कितना आ रहा होगा, 0 आ रहा होगा, क्योंकि ये पॉजिटिव चार्ज इसको इधर रेपेल करेगा और ये पॉजिटिव चार्ज इसको इधर रेपेल करेगा, नेट फोर्स 0 हो गया। लेकिन जैसे ही मैं इस चार्ज को स्लाइटली मूव कर दूं, क्या कर दूं मैं, स्लाइटली मूव कर दिया मैंने, इसको स्लाइटली मूव किया, ठीक है, टूवर्ड राइट और लेफ्ट एज यू विश। इफ आई मूव दैट चार्ज टूवर्ड राइट बट द डिस्प्लेसमेंट इज टू स्मॉल, ठीक है, जो आपने इसको डिस्प्लेस किया है वो बहुत कम होना चाहिए। ठीक है, अब ये थोड़ा सा मूव किया अपन ने, और मान लीजिए मैंने ये डिस्टेंस मूव की है। इफ आई डिस्प्लेस इट विद एक्स डिस्टेंस, so what will happen, now the charge is at this position and the distance of that charge from this one is a plus x, that is a plus x, and the distance from that charge is equal to a minus x. Okay, isn't it? It is a plus x and it is your a minus x, that is the distance. And if we consider about force, the net force will act right side or left side. Net force, I am asking about net force. Let us see. The distance a minus x is very small, so that's why the force due to that charge will be larger than this one. Let us see. That is plus q and that is your plus q. The repulsion force will act toward left due to that charge, and in the same way the force exerted by this charge on that is toward right side. So that is F equal to K, okay, Q upon, what is the distance, a minus x square, a minus x now square. If I consider the force that is due to that charge, so F is equal to, if I say that is F dash K Q upon square of the distance between these two, that is a plus x whole square. Okay, so the net force is what, F net, that is equal to K Q upon a minus x square plus, sorry, minus, why, because these two forces are in opposite direction. So K Q upon a minus square minus K Q upon a plus x whole square. That is your F net, and the direction of F net is toward left. Okay, so why I'm telling you, why I'm finding out the F net resultant force. Okay, we can say resultant force or net force. Let this see this example. If the distance is less, that force will more than this. है ना? The second point is what? I am displacing that charge with a short distance, with a small distance. Okay, it is slightly displaced with x. Okay, it is slightly displaced with x distance. So what will happen? The restoring force, or we can say the net force, which is acting on the charge, is toward left side, and the neutral, or we can say the net force is 0 at which position? At the midpoint. At midpoint the net force will be 0. There will be the force is equal to 0. It is discussed, it is discussed already that the net force is equal to 0 at midpoint. Okay, so what will happen? The restoring force on Q will act toward the equilibrium position. That is equilibrium position. The charge will move toward the equilibrium position. And when the charge is moved toward the equilibrium position, or we can say it tries to move in the equilibrium position, so the acceleration is proportional to negative of x. Why? Because the net force or restoring force is acting toward the equilibrium position, but we displace the charge toward right direction, toward that charge, or we can say x is opposite to the a means the direction of the force, we can say. Okay, the direction of the force is same as acceleration, so a is proportional to minus x. So it is the equation of SHM. It is the equation of SHM. So that's why we are saying that that charge will execute SHM. What will happen when that charge is at the midpoint? After reaching at midpoint, due to inertia, it will not remain in that position. In that position means it will not remain at midpoint. It will move toward left side. Why? Because of inertia. Even the force at the midpoint is zero. So it will execute SHM. It will move beyond that equilibrium position, and again now the restoring force is acting toward that charge. Why? Or we can say toward equilibrium position. Why? Because when the charge is moving toward positive q, the distance is now small, and due to small distance the force will again increases. The force will again increases due to that charge. Okay, so we can say, if I consider that charge move beyond this position and placed there, so now the force due to this charge on that charge is greater than this force. So again a is proportional to negative of x. Now the restoring force is toward equilibrium position, and the distance, or we can say the x, is toward what? Left direction. Okay, so that's why again a proportional to minus x, and this process will continue. Okay, if there is no any friction and whatever, okay, if there is no any losses, so it will execute continuously SHM between these two charges. Okay, so we have proved that the charge will execute SHM. So the net force is what? KQQ upon A minus X square minus KQQ upon A plus X whole square. So if we find out that net force, let us see KQQ, and the LCM is what? A minus X and A plus X square, and that is square. So we will find that A plus X square minus A minus X square. Okay, that is our F net. That is our F net. Can I erase it? Okay. So now only a simple mathematics. Okay. The F net is equal to KQQ, and you will see A square plus X square plus 2AX minus A square minus X square, and minus minus plus 2x, so that is your 4ax, and the denominator is a square minus x square and complete square. Why? A minus b, a plus b, and we can also replace this square, or we can say power, to that point. Okay, that whole square. Okay, a minus x, a plus x whole square. So a plus b, a minus b, a square minus b square, that is square, and x is very less than a. It is discussed. So F net is equal to KQQ upon 4ax upon, now see x is very less. Okay, x is negligible as compared to a, so that's why a की power 4. So aq, that is F net, that is equal to KQQ 4x upon aq. That is the F net, or we can say restoring force. We can say restoring force. Okay, that is our restoring force. Now, and I am again saying this will execute SH. So A is proportional to negative of x. So if the mass of that charge Q is m, what is m? So F net is equal to ma. So A is equal to F net upon m. And what is your F net? F net is what? KQQ 4x upon aq, and that is m. And one more thing, acceleration is opposite to the x, so that's why there will be a negative. So I am placing a negative sign. Okay, so A is equal to minus KQQ 4x upon ma cube. A is what? A is not acceleration. Okay, A is what? That is your acceleration. I have to place that is acceleration. Okay, that is your acceleration. It is the dimension. It is the dimension. So it is your acceleration KQQ 4x upon ma cube. Negative. Okay, why negative? Because F, or we can say acceleration, is an opposite direction to the x. Okay, A is opposite to the x, so that's why we are placing negative sign. And we know that we compare it with A is equal to minus omega square x. It is discussed in SHM chapter. Okay, chapter simple harmonic motion. A is equal to minus omega square into x. So again I erase it. So compare this equation to this equation. That is acceleration, that is also acceleration. It is not dimension. Okay, again remember that. So that is x, that is x, that is negative, that is the omega square. So omega square is equal to 4kq upon ma cube. So omega is what? Under root of 4k cube upon ma cube. Okay. And if I say I want to find out the value of time period, so that is omega. So 2 pi by t is equal to under root of 2k cube upon ma cube. And again I have to erase it because of shortage of the whiteboard. So place, so then time is equal to, what is it? 2 pi, okay, under root of ma cube upon 4k cube. That is the time period. That is the time period. So in the next lecture we will find out the time period if I move that charge perpendicular to the axis. Okay, the line joining of the charges perpendicular to the line joining of the charges. If I displace the charge in that direction, or we can say in that direction. Okay,